Hello everyone, and welcome to this new chapter which is called optics. So we will be learning about this optics in detail in this particular chapter. And prior to this chapter, we have not talked about anything related to light, and here we will be dealing with this light. So what the optics is, if we are interested in finding the definition, so we can say or we can define optics as a branch of science that deals with. So this deals with study of light. You might have some basic idea about light. So we will explore those ideas and we will proceed further, right? So you must be knowing that the light is having a dual nature. So it has a dual nature. What does that mean by saying dual nature? Dual nature basically indicates that light is both having a particle nature as well as wave nature. So light is made up of particles as well as it is also a wave. Now when we call it as a particle, then what type of particles they are and how they move, all those stuff we are going to learn later on. But some points that are so obvious that you should know, these particles are called photons, and these photons are very different from the particles that we have uh, studied so far. That's a materialistic particle. So they are different particle, different from these materialistic particles. Then as wave, what type of this wave is, that also has to be understood. So we have talked about waves like mechanical, non-mechanical, transverse, longitudinal, and all that thing. So here we will say this is a wave which can be called as electromagnetic wave. Electromagnetic wave. And this electromagnetic wave is both transverse in nature and non-mechanical in nature. That means it does not require medium to move. So that means light can also move in space that does not have a medium. That means it can move in vacuum. So whenever it moves in vacuum, it got its velocity, or it also got velocity in medium as well, right? So speed of wave or this light we talk about, so we say this speed is defined as v is equal to this c by mu, some sort of this, where c is a number, that is a fixed number. It is 3 into 10 raised to power 8 meter per second, and v is the speed in any medium. So that is also called the speed of light in vacuum. So speed of light in vacuum, and mu is medium index, and that decides the speed of the light in any medium, and this mu is called as a refractive index. Refractive index, or we also call it as optical density. Optical density of medium. So depending upon optical density of medium, you will find its speed varies. And you can think of for vacuum mu is 1. So for vacuum it is the fastest speed. So this c is the fastest speed, and uh, in any medium you will find the speed of light will slow down as compared to that in vacuum. So vacuum has the maximum speed. Okay, and both photons or wave, either way you are considering it, they will be following this speed depending upon the medium. That means the speed depends on the medium. So study completely about optics or light, we can have some types or some divisions, like whenever we are talking about this wave nature, so we will be calling is a some part of the optics called wave optics. Then we will be dealing this particle nature separately. It will be known as the particle nature of light, and one common that you know is geometric optics. So if we talk about the types, so there are, let me write over here, type, or you can say division. Here the type means the division in which we are doing this optics chapter. So first we will talk about is geometric optics. Geometric optics. In this geometric optics, we will be neither considering this particle nature nor wave nature. Basically, it's a wave nature, but with some conditions. So it's called geometric optics. Sometimes it's also called a ray optics. Ray optics. And the second would be wave nature of this. So we will call it as a wave optics. So chapter will be known as, or sub part of it will be known as wave optics. Then there will be third. This third is going to be known as particle nature of light. Particle nature of light. So we will be studying this in these three divisions. Okay. Now we will be studying all these three segments of this chapter separately. So first we will focus on this ray optics, or which is geometric optics. Then we will move towards wave optics, and then finally we will go towards particle nature. So we will follow the same sequence. So now let's go for this geometric optics. Yes, so here we will be studying about geometric optics, or we can call as a ray optics. So what will be the main focus area over here? Here we will be studying about formation of images. So geometric optics basically deals with formation of images and their analysis. So we will see where the objects are being formed and what the size they carry and related stuff. And in this particular branch or sub branch, you will find we will use the concept called rectilinear motion of light. So rectilinear motion of light. So this is based on rectilinear motion. And how we can justify this rectilinear motion? This rectilinear motion of wave will be justified if the image forming object is having more dimension than the wavelength of this. So we can say its validity is when mirrors or lenses, we can write over here, mirrors or lenses have dimension more than wavelength of light. And if you look at the wavelength of light, then you'll find this wavelength is very small. So even the small mirror and lens can be used for making this formation of images, and we can have this consideration or assumption that light is moving on a rectilinear path. Now you can understand this point even better way if we consider this. Let's say this is the wave which is moving, right? And this has a significant wavelength. If the wavelength is very small, then you'll find the wave will be some sort of this, right? It's a very small wavelength. And if it is very small, then you'll find it will be almost a straight line. So this tends to almost a straight line if we consider the object which is significant high, so that the wavelength appears very small. So if wavelength is small, then it can be correlated with linear path. So we say this is the light movement. So this is a wave movement, and this is a wave movement. This is also a wave movement, but this can be simply studied as a rectilinear path. So this we called as a ray. So what is a ray? Ray is basically a straight line, and that indicates the direction of light movement. Okay, and that's called a rectilinear motion of light. and that is an assumption we take to make this to study the formation of images, how the images are going to be formed. We will study based on this, right? And this will be valid if wavelength appears smaller as compared to the dimensions of mirror and lenses what we are going to use. So that's important point we need to keep in mind. Now this once we have understood ray, then there is a term called beam of ray. Beam of ray or rays or beam of light, but basically we say it a beam of light. So what is a beam of light? It's a bunch of rays or collection of rays. So you can say it's a collection of rays. So if you collect the rays together, so they together called beam of light, and they can be of the following types. If you look at their types, then either you will get this kind of light rays coming in. If you're finding this type, so they will be known as parallel beam of light. Parallel beam of light. Or you may find this type. So you'll find this is converging nature. So converging beam of light. Or you may find this type. That means they appears to coming from a source, point source, so they are called diverging beam. So that's a diverging, that's parallel, that's a converging. So this is how we categorize beam of light, and which is collection of rays. Now let's move ahead and talk about how we define object, how we define image, and then further things. So what is an object? Basically I'm talking about the point object. So whenever we are looking for a point object, we can define that it is point of intersection, point of intersection of incident rays. Incident rays. So whenever the incident rays, wherever they intersect, that point of intersection is known as object. What the whole idea is, that is this: there's going to be some optical instrument or device, maybe mirror, maybe lens or something like, and you'll find some light ray will be falling on it. Maybe this is a beam of light that is going there. So I'm showing single light, right? So this will be undergoing two stuffs. It might be reflected back in the same medium, or it will be passing through to the next medium. Maybe some sort of this. So you'll find nomenclature goes like this: the one which is falling on this, that's called incident one. Incident ray. And the one which transmits this optical device and goes to the next side, so that's called refracted ray. And the one which returns back to the same is called a reflected ray. So this is the nomenclature you might be knowing, and now otherwise you can remember now. So there's one single ray I have shown. There will be multiple rays coming in. So wherever these rays are intersecting, that point of intersection is known as point object. Okay. For instance, now let me give you an example. In this example, let's say this is some device. Let me draw some proper. And in this device, let's say lights are shown given to us. Maybe this. Maybe this is one of the rays. They are straight lines. So you can see what type of this beam is. This beam is getting converging somewhere, right? And these are incident rays. So you'll find you need to look where the point of intersection is going to be. If you produce this backside, you'll find there will be no point of intersection feasible in the backside. So where it is feasible, it's feasible in the forward direction. So you take it take it, you take it, you'll find they will be meeting at this point. So this point will be known as object. So what is object? Object is the point of intersection of the incident rays, right? And wherever they meet, that point is known as point object. This is how the object is being defined in any case in ray optics. Moreover, we categorize this in two ways, like a real object as well as imaginary object. So you'll find if for instance in this case they are converging, so there's a converging beam of light, right? So that is going to be known as imaginary object. So let me write here, if incident rays converge, then the object is virtual. This is important point to remember, or you can say imaginary. And if incident rays diverge, that means they are diverging from a point, then the point object is real. This is how we can categorize the object and their nature, right? So if they are converging, then that point object is virtual, and if it is diverging light rays, incident rays, then you'll find it is real. So can you answer this, what type of this object is, whether it's a virtual or real? So you'll find this object is basically virtual. Similarly, can we find the real as well? Yes, we can definitely find the real as well. So in case of real, you can see this example. There will be some object and light rays will be moving like this. So real object means object is emitting light rays, and then it is going to fall on some instrument, and what happens later on, that's a different story, but we can find what type of the object this is. Similarly, we can also understand what the image is going to be. So image is going to be formed after meeting the boundary. So there will be reflected or refracted rays. So we can say it is point of intersection of reflected or refracted rays. So whatever the phenomena is taking place, accordingly we can form the image by looking at the intersection points of what? Reflected or refracted rays. Then we can say when this is going to be real and when this is going to be imaginary. So image will be real if these reflected or refracted rays are converging in nature. If refracted or reflected rays converge. Can you remember this? And the image will be known as virtual image if refracted rays diverge. So if you remember for the object, just opposite you can make it for image, and you'll find you can decide whether the image is real or it is virtual, right? For instance, let me draw this device. So if this is a device, and in this device some light rays are shown like this. So let's say this is the case. One light ray is coming here, another is this, another is this, and then after rays are shown like this, maybe, or any of them, right? So here we should be able to decide what type of the object and what type of the image is. So these are the incident rays, so they will be deciding about the object, and this is very similar case that we have already done. So they are converging. Since they are converging, so object must be virtual. And these are the refracted rays. Now if you look at these refracted rays, then you'll need to find these rays are going to diverge from certain point this side. So since they are diverging, so we'll say image is going to be here. That's image, intersection point of these things. And this image is going to be what type? Can you think of? They are diverging, so diverse condition says this is a virtual one, so we'll call it as a virtual image. So this is an example in which the object is also virtual and image is also virtual. This is a theoretical example that we can use for finding the location of image as well as location of object, and we can claim which is real, which is virtual. Okay. Now in order to make image, then the two types of phenomena are important. One is reflection of light, another is refraction of light. So first we will focus on reflection of light. So how we decide the reflection of light and what they are, everything you are going to learn over here. So when we say there is a reflection of light, so light is going to move in one medium, then meet with some boundary, and if meeting with some boundary, if it returns back to the same medium, so let's say this is a boundary, and let's say this boundary is shaded from this side, and any light is moving towards this, and when meets this boundary, then you'll find it if it returns back to the same medium. So we call this is a concept of reflection. Now in particular medium, this is a single medium, right? This was a different medium. So in single medium, light moves in a straight line path. It moves on a straight line path, rectilinear motion, and having the same velocity. And then after it turns, reflects back, that means return back to the same medium. So we can say reflection is a phenomena by which the incident ray after striking at the boundary returns to the same medium. So we can write in short, if a beam of light, or maybe single ray, a beam of light returns in the same medium, or returns to the same medium after striking or after incident on a boundary between two mediums. So if it returns back to the same medium, that phenomena is called reflection. Okay. And in case of reflection, you'll find, in case of reflection, since these are the waves and waves are reflecting back, then you'll find there will be no change in the speed. So you'll find the speed, wavelength, and frequency of light, because light is electromagnetic wave, so they carry all these things, remains constant, remains same. So all remain same after reflection. So after reflection, you'll find there will be no change in the speed, wavelength, or frequency of this. And since it remains the same medium, so speed does not change, hence frequency, hence wavelength. Frequency depends on the source, so that does not change. Even there is a change in the medium, you know that point, right? And to study this, there are called laws of reflections. Laws of reflection, so we can think about laws of reflection. So reflection has two laws, and these two laws we can write down over here. So first law, it says incident ray. Incident ray. Here we can read which one is the incident ray. And then a reflected ray. We can read which one is a reflected ray. And then finally normal. So this normal is also very important. Normal at the point where the light strikes. So for instance, in this figure you see at this point it strikes perpendicular to the point on where it strikes. So that's called normal. And this is incident ray, this is reflected ray, and this is talking about all these three rays. So incident ray, reflected ray, and normal all lie in the same plane, That means you can see in this picture all three have been drawn in the plane of the screen, hence they are in the same plane. Neither of them can go outside this plane. Then the second law is angle of incidence and angle of reflection are always equal. So they are equal in case of reflection. This is how the reflection takes place, that you'll find the angle of incidence and angle of reflection are going to be equal. So how we measure the angle of incidence? Angle of incidence measured from the normal and the incident ray. So this angle is called angle of incidence, and this angle, that means from the normal to the reflected ray, is called angle of reflection. So R. So we can write angle of I is equal to angle of R. So these are the two important laws related to reflection. Now based on these two laws of reflection, we will be learning how the beam of light gets reflected. Then we can see whether they are getting converging after reflection or they are diverging after reflection. Then we can find the point of intersection, and hence we can find the image, right? So this is the basic law of or laws of reflection. Okay. Now this reflection can take place from a plane surface or maybe from the curved surface. So if this is plane, so we call it a plane surface and plane mirror basically. And if it is from the curve, so we call it as a curved mirror. In curved mirror, our focus will be on the spherical later on, but principle will remain the same. So what we are going to say in this case, if you find if any light beam is falling like this, then you need to search for the normal. First you need to search for the normal, and then you say whatever this angle is being formed, at the same angle you take this other side, making the same angle, right? So you'll find whatever this angle was, same angle has to be drawn over here from the normal. Now in case of plane mirror, one thing is very easy, that at any point the normal is going to be parallel to each other. So all the normals will be parallel to each other. However, this will not be the case over here. Here the normal will be like this, whereas here the normal will be like this. Similarly, normal will be like this. Normals will not be parallel. Since normals are not parallel, hence we need to be careful in designing the incident angle and the reflected angle. So at whatever the point the light beam is getting incident, so what we need to do at that point, we need to draw the normal. So we need to draw the normal at the point where the light this incident happens, and this angle will be angle of incidence. So whatever this angle is, by same amount you need to go in that way, and you'll find this angle will be angle of reflection. So the two are going to be equal, right? So point that is critical is drawing the normal. In case of plane mirror, you'll find all the normals will be parallel to each other, whereas in case of curve mirror they will be different. So in case of curve mirror, it becomes very challenging to identify the normal. Out of all the curve mirrors, you'll find sphericals are easy, because in sphere, if you draw this sphere or some sort of this geometry, then you'll find in that sphere all the normals will pass through from the center. So if you need to draw the normal here, then you'll find the normal will pass through the center. Similarly from here, so the normal will pass through the center. So at all points you'll find the normals will be passing through the center. So hence we use this normal we can draw these normal easily, hence we will be studying in curved mirror the spherical ones, right? So that will be easier for us to draw the geometrically and draw the normal. Once we are able to draw the normal, we can measure the incident angle, hence we can measure the other stuff, right? So this is about basic about reflection of light. So in this very basic video regarding optics, we talk about what the optics in optics we deal with, what are the sub branches that we are going to study about. And in geometric or ray optics, we study about the rectilinear motion of light by assuming that the object we are using, they are large enough as compared to the wavelength of light, and they are normally large enough, so that assumption is quite valid. And the first law that we talk about related to reflection. So reflection laws you got to know, and we are going to use this in image formation. Okay, so in the next video we will talk about ahead of this. So make your notes. Thank you for watching. Have a great time.